Hi. Yesterday we learned how to solve systems of equations like this by drawing the graphs of both equations on the same grid and looking for the point where they intersected. This lesson is about using something called the substitution method, where we get two equations sort of smashed together into one equation with just one variable by substituting for one of the variables. Now, that's a bunch of words, but here's how it works. You take a look at your two equations and think, how could I get one variable all by itself in either one of them as easily as possible? And in this example, the first equation already has y all by itself. It says y is the same as an x plus 4. So we're going to use that as that x plus 4 as a substitute for the y in the second equation. But here's what I mean if I write it out. I'm going to write 2x minus, copying that second equation, except I'm not going to put a y there. I'm going to put a big parentheses, a parking space, for what I'm going to substitute for the y. I'm allowed to substitute for the y what the first equation says is the same as a y. The first equation says an x plus 4 is the same as the variable y. So now I've got a new equation, a combination of these two that I got by substituting, and it's all x's, so I can solve this for x. Let's see how that goes. I've got 2x, take away the parentheses, so that's take away x, and it's also take away 4 equals 6. 2x take away 1x, that's just 1x. So I have x minus 4 equals 6. And now I would add 4 to both sides. And doing that makes it say x equals 10. So I've got part of my answer here. I know that x is equal to 10. And then to get the other number, the y value, I can go to either one of the equations and insert the 10 for the x. And the first one's nice and easy to plug in. If I put a 10 for x right there, it's going to say y equals 10 plus 4. So y is 14. And there's my finished solution. If I want to make sure this is correct, it should be that when I use these numbers in both equations, I get two true statements. In the first equation, if I write 14 for y, does that equal 10 plus 4 using the 10 for x? And of course, 14 does equal 10 plus 4. That one's pretty obvious. The second equation, it says 2 times the x number, take away the y number, is supposed to equal 6. So if I put the x value I obtained in there, 10, and put the y value in here, see 2x minus y, put the y value in there, does this really work? Well, 2 times 10 is 20, and 20 minus 14 is 6, so it does work. That convinces me 10 comma 14, 10 for x, 14 for y, is the correct solution for this little system of equations. Okay, I'm going to stop the video and make a second video with another example.